So welcome to this talk on climate change impacts on UK's butterflies and moths. My name is Simon Saville. I am the chair of the Surrey and South West London branch of Butterfly Conservation, live in central London and spend a lot of my time looking at the butterflies in the parks and green spaces in the capital. The picture you see is one I think is probably familiar to many of you. They're called warming stripes and generated by Professor Hawkins at the University of Reading. And basically what these do, each stripe is a year, and it's based around the average temperature between 1971 and 2000. And anything cooler than that is blue, and anything warmer than that is red. And this goes from 1970 to 2019, so it's the latest ones. And it's obvious here that the UK is getting warmer over that period of time, even that short period of time. So what I'm going to cover, I'll talk about the climate emergency. If you don't believe in the climate emergency, that's really happening, then you're probably in the wrong talk. I'll describe why Lepidoptera are good indicators of changing climate. We'll talk about distribution changes, phenology. We'll also discuss why averages is not the most important thing. And then finally talk about what we can do and draw some conclusions. And on the right, you've got some common butterflies in Burgess Park this spring. And they're, as you're probably well aware, climate winners in all this changes. So first of all, the climate emergency. This is the monthly average carbon dioxide temperature in Hawaii on the observatory there from 1970 to 2020. And you can see that the CO2 levels have risen relentlessly. That's not quite the right word because it's accelerating. Back in the 60s, it was a 0.6 ppm per year increase. And in the recent decade, it was 2.3 ppm per year increase, which is 4 times faster. You will note also no blips for recessions, no change for the pandemic, and no sign of the trend changing despite all the COPs we've had, all the promises and everything that's been going on. So temperatures continue to rise, and you'll be familiar with this chart. This is taken off the BBC website. Global mean temperature change from pre-industrial levels. And you can see, particularly post-war, how the temperature just goes up and up and up. And on the right-hand side, there's a picture from 2019, the highest ever UK temperature, 38.7 degrees in July in Cambridge. So it's getting hotter. And the future looks hot too. This is another graph of monthly average CO2 concentrations. And as I pointed out, lots of promises, not many concrete plans. We're set to exceed 1.5 degrees heating, almost certainly. What politicians don't tell us is that the underlying driver of all this is consumption, so growth as measured by GDP. And as long as we continue to grow in the way we have been doing, CO2 levels are almost certainly going to continue to rise. And we can talk about that in the Q&A if you like. I got this off the BBC website as I was researching. So we're talking about in London, what the predictions are for hot summer days. It doesn't define summer very accurately, but I presume it's June, July, August. And you can see currently we're looking at about 6 days above 25 degrees C per month on average, so 1 in 5. At 2 degrees warming, you're going to 1 day in 3 per month above 25. And at 4 degrees warming, you're going to 2 days in 3 above 25 degrees C. That's pretty big changes. So the future looks hot. And I was chatting to someone today as we were walking around Mitcham Common, and she said to me, what's the effect of climate change on insects? Isn't a warmer climate better for them because they like the warmth? Well, as we'll find out, it's not quite as simple as that, because not only hotter summers, but warmer and wetter winters and more frequently occurring extreme weather events. And this is a picture from Burgess Park near Elephant and Castle in central London, fairly close to me. And you can see what it looked like in August last year in the drought we had then. I should say that I've taken a lot of this talk from a presentation done by Richard Fox at the BC Butterfly Conservation AGM last November, and modified things and added to it and taken things away. But this is a slide that Richard used, particularly the small skipper, picture on the right. So 3 reasons why butterflies and moths are good indicators. First of all, they're sensitive. Because they're ectothermic, cold-blooded, rely on the environment to monitor their temperature. and at the climatic range margins in the UK. So you can see the small skipper here. The dark coloured area is its range in the UK. And you can see being at the limit of that range means it's very sensitive to changes. And this is from research done quite a long time ago and presented in academic papers. The second thing is that they can change fairly quickly. So they have high reproductive rates, 1, 2, or 3 broods per season. They work on pretty short life cycles, and they can disperse quickly, as we'll see. Butterflies are dispersing quickly and moths across the country. And they're well studied. We've got long data sets by enthusiasts going back many years, and the data density continues to increase. So here we've got some of those long-term data sets which BC has been involved in mostly. So the butterflies for the new millennium data set, 15 million records. National Moths Recording Scheme, 26 million records. UK Butterfly Monitoring Scheme, weekly monitoring since 1976. And the Rothamsted Insect Survey, 500 sites on a regular basis. And you can see the density of information which is generated on the species richness map for the UK for moths, taken from the UK Moth Atlas that's just been published by BC. Astonishingly, in 10 kilometres squares in the south here, over 500 species recorded. So we've got a lot of data. So a lot of studies can be done. And first of all, I just want to talk about distribution changes. And as you'll be familiar, I'm sure, there have been winners and losers in this. The main driver probably being climate change. If you live in London or towards the north, you'll be seeing more speckled woods and comma butterflies than you have been seen in the past. The comma has been the most common hibernator to be seen in springs in London for some years now. That's my anecdotal views. The brown argus, as we'll see, has moved in, spreading, and it's now widespread in London as well. And the Jersey tiger moth, which really appeared first in London in 2004, is now very, very prevalent across London, and they're spreading out even further. So it seems to like it here. Meanwhile, we've got the losers on the other side. The wall brown is a familiar story, which we'll talk about in more detail. And these northern species, which are more cold adapted, the Scotch argus, mountain ringlet, northern brown argus, are all suffering as well. So winners and losers on the distribution front. So here's the comma. And as you know, it's at the northern limit of its range in Europe. And I'll show a number of these pictures where taken from the State of UK Butterflies 2015, the new book due out shortly or in the next couple of years. The dark dots, purpley dots, show what was there 1970 to 82, where the distribution was. And then the orange dots show 2010 to 2014. And you can see how much the comma has moved northwards since that time. An astonishing 450 kilometers, 11 kilometers per year. I would say it probably also due to it using nettle as food plant, not just hop and elm, but certainly much more favorable climate for it in the north now than it was. And it's even gone further than this, right into the north of Scotland now. The brown argus, another success story. You can see its previous distribution really showed the chalk and limestone grasslands in the UK. So the Chilterns, the Cotswolds, North and South Wales, the Dorset and the Jurassic Coast, South Downs, North Downs, Kent Downs. But since 2010, it's been much more widespread. And part of the reason is it's flipped to feed on geranium species, not just common rock rose. It's much more widespread food plant for the larvae. So it's able to take advantage of the warming climate. This is a picture from Burgess Park here in London. Marbled white, another one which is spreading across London, and that likes tall, unimproved grasslands. And as the parks in London are doing a better job of managing their grassy areas for wildflower meadows, we're seeing more of the marbled white, and it's moved into parks around southwest London, southeast London now, and spreading further. I put the diagram at the bottom there on purpose to show that this species spends a lot of time as a larva. And so the climate conditions as a larva will be very important to its survival or not. And we'll talk about that a bit more in the future of this talk. And this is the occupancy trend for the marbled white in Surrey, Vice County 17, the Surrey and Southwest London area. And you can see it's spread massively in the last 30 years. And it's now seen in more than 2/3 of the tetrads for 2 by 2 kilometer squares in the branch area. And you can see more detail of that in the branch website if you want. The speckled wood is another example of spread north, and as you can see, it's across nearly the whole country now. But one of the things I wanted to mention here is that there are lags between climate change and species responses. So people have done studies of the favorable weather conditions in different parts of the country and where butterflies should be able to be present but aren't. So something else is holding them back other than the weather or the climate, and that's probably habitat availability. And you can see this is probably affecting the speckled wood in the difference between Scotland and Yorkshire, where it's spreading faster in Scotland than it has been in Yorkshire, because probably there's more suitable habitat for it there. And then moths. This is taken from the State of UK Moths 2021, which is just published. It's a really good summary of how moths are faring and how things are changing. This looks at the number of species and the range margin change per year for 487 species of larger moth in Britain from 95 to 2016. And the statistically significant changes are shown in the darker shade of green. And positive values means that the range has shifted north. So some haven't shifted, but on average, there's a northward shift of 5 kilometers per year, and some are shifting north at 2 or 3 times that, or even more. So we tend to think of butterflies and moths and what's the wildlife we see as static. What's there has always been there, but UK's flora and fauna have been changing on a continuous basis, and we're just seeing more change with different drivers now. And this is also taken from the State of UK's moths. I rather like this Footmen March On graphic, which they had in there. And this shows 4 different species of Footmen moth, showing how it's spread since pre-2000 days. And again, pre-2000 is the purpley blue color, and the new squares are for in orange at 2000 to 2016. Because the larvae of this species feed on lichens and algae, it's probably a response to warmer climate and reduced air pollution as well. We're definitely seeing the lichen feeding species in London faring better, which is probably as much a air quality effect as it is to a climate effect. Tree lichen beauty is now common in London, for example. But it's not all winners. There are losers here, and the grey mountain carpet, again from the State of UK Moths publication, which likes cooler, damper climates. You can see how that's contracted. I say retreating north, but it's mainly up, going to higher altitudes where it's cooler, and a massive decrease in distribution since pre-70 days of 81%. The mountain ringlet, this is a graphic from Franco et al. Again, quite old, but it's a little difficult to interpret, but you're looking at the percentage of squares where the butterfly has gone extinct on the vertical axis, and on the horizontal axis, elevation, and there's 3 bands of elevation from low, medium, and high. And at lower elevations, there are higher extinction rates, showing this mountain ringlet is basically becoming extinct at locally extinct at lower elevations and retreating north into higher ground. So there's going to come a time probably when there's nowhere for these cold-loving species to go, and that spells doom. And then we all know, if we've been watching butterflies for any length of time, we wonder why there aren't so many tortoiseshells around as there used to be. Malcolm Hull from the Herts Middlesex branch has done some interesting work here, which is published in the Butterfly magazine, or you do need a member login to see it. But what we're seeing there in he's spotting is that they're going into hibernation very early in July. And I wonder whether this is an escape from the warmer weather. And the peacocks there, you see hibernating, were in a pillbox on the North Downs in Surrey at the beginning of August 2019. So again, early hibernation. And having been in Japan for some time, I recognized there that the small tortoiseshells are essentially an alpine species. So I think some of these hibernators are cold adapted And when it gets warm in the summer, they can't cope and they just hide away. And that might be one reason why we're not seeing so many, aside from predation by Sturmiobella and other things for the small tortoiseshell. But I think cold adaptation is something which some of our species have and will suffer as the climate warms. And now looking at abundance and distribution. So we've talked about distribution increasing for some species, and this is taken from Moths, from the Atlas of Moths, which BC published 18 months ago. A fantastic book. This looks at 104 species of moth in Britain over the last 40, 50 years. Looking, this is for the species where there are statistically significant changes in abundance and distribution. And in this graph here, I've plotted distribution on the horizontal, from increasing distribution in green going right, decreasing going left, and abundance increasing as you go up and decreasing as you go down. And you can see what you would like to see is species in the top right-hand corner increasing in both abundance and distribution, but only about a fifth of the species are doing that. And the spruce carpet being an example that's picked out in the report. So maybe 1 in 5 species doing well. No species increasing in abundance, but decreasing in distribution, but quite a lot of species below the line, as it were. So they're decreasing in abundance, but about a quarter of the total species were decreasing in abundance, but spreading their distribution. But over half of them are decreasing in distribution and decreasing in abundance. And this, of course, is the extinction quadrant, because as you go and move down further and further here, you eventually become extinct. So these distribution changes, while they might be quite welcome, they're not associated with very often with increases in abundance. So we should still be worried. And that's probably down to habitat quality, which we could talk about later as well. And then, of course, we get new arrivals to Britain, and the moth, and particularly the moth fauna in Britain, is not static at all. And since 1900, you can see over 137 species have become established and 51 have gone extinct. And more recently, even since 2000, 53 species have arrived or returned, some naturally and others been unwittingly imported. I just mentioned 2 because they've both been controversial in the London area. The box tree moth, which you can see a picture of there. It's quite a nice, it's actually a micro moth officially. First seen in Kent in 2007, is now widespread across all of London. And it's brought in on imported box plants, so biosecurity was a problem. And you can see what it did to the box hedge in my front garden, which I took out afterwards. Had a really good year in 2018 in London, and then crashed in 2019, probably because it ate all its food. And the oak processionary moth of Central and Southern Europe, by 2006, it was resident in Southwest London. It's now well established in parts of London and Southeast England, and the Forestry Commission has an attempt to control that with spraying, which is controversial in many circles. But both of those moths would seem to be here to stay, whatever we want to do with them. And here I've just listed some future, maybe possibly current residents, I don't know. The long-tailed blue is a migrant seen in increasing numbers. People in Sussex will probably tell me it's resident there already. The large tortoiseshell is seen on Portland Bill regularly, may have been introduced as well, but it's possibly breeding there. And the southern small white is kind of massing on the continent, ready to invade in Britain, southern Britain. But amazingly, it says it's spreading at 100 kilometers a year, which is astonishing, isn't it? So we will have new arrivals, no doubt, in Britain in the coming years of butterflies as well as moths. Now I'm going to talk a little bit about phenology. I'll talk about Nature's Calendar, which is a citizen science initiative. We'll talk about moths, because there's some good data in the Atlas of UK moths. We'll talk about the differences between single and multi-generation species and the developmental trap of an extra brood, which is well known now, and how maybe some habitat specialists' early emergence is being correlated with decreasing abundance. But I put the picture on the right here, because this is from a park in Southwest London, SW20, on the 1st of July last year. Ripe blackberry. It wasn't very sweet, but it was at least ripe. And if you Google blackberries, it says normally at the best at the end of August to September. So we've definitely got something going on here. And that could be also associated with London's urban heat island effect. And this is an example, it's quite an old example from 2003, although reported in a paper about 10 years later. But London's temperature in London, particularly in central London, inner London, can be 4 degrees, 7 degrees, even more higher than the countryside around, especially at night as well. So you've got a microclimate in London, which is quite different from the surrounding area. And as an example for that, this is what counts as a cold night in London. This is outside my house, -1 degrees on the 8th of Feb. I think it was about -19 in north of Scotland at this time. And we had literally 5 days below zero, 5 nights below zero in London here. So really not a cold winter at all, but that's becoming the norm. Climate change plus urban heat island effects. I mentioned Nature's Calendar. This is the initiative by the Woodland Trust with the UK CEH, funded by the People's Postcode Lottery. And they ask people to record the dates when things happen, like bud burst, first leaf, first flowering, and so on. And I don't want to go into the detail of this, except to say that this compares 2018, 19, and 20 versus benchmark 2001. And negative numbers mean things happening earlier in the year rather than later. And if you just, I take a look at the 2020 column, you can see how much earlier some of these things are happening versus the benchmark year of only 20 years ago. So interesting that that's been done, and it's good citizen science, and I think it'll be a useful measure for the future. Now just a couple of phenology changes taken from the State of Britain's Larger Moths report that came out this year. You can see the grey birch is now flying several days earlier. The peak is several days earlier than before. And the sharp-angled peacock is not only flying earlier in the first brood, but it's got a much more marked second brood than it had before. And probably the second brood is looking more like it's the dominant one now. So quite marked phenology changes in quite a short period of time. So looking from 1970 to 1979 versus basically 30 years later. But some species of moth are flying later. And this looks at data from the atlas again. 19% of the species looked at were flying later, and at least some of these at least 7 days later. This is the pink-barred sallow flying later in the season because it's now warmer in September and October than it used to be. So big changes. But things get complicated. This is an excellent paper by Callum McGregor and co in Nature Communications from 2019, looking at the effect of how many broods there are, volatinism, on how they respond to phenology changes. So on the left, you've got the silver-studded blue, and on the right, the small blue. Silver stud, of course, has got 1 generation per year, and the small blue has 2 generations. The silver-studded blue is declining in abundance and retracting its range, whereas the small blue is increasing abundance and expanding its range. And it's posited that this is probably due to a larger second brood. People on the call may know more than I do, but I think it's interesting that things quickly get complicated as you get into details of different species and different volatinisms and so on. And now the wall brown, familiar story, I think. This map on the right compares number of sightings seen at different times. And you can see all these light blue circles here are old records. And basically the whole, this was a common butterfly in farmlands. I used to see it growing up in Dorset on a regular basis, but it's largely extinct now in the central part of England, and it's restricted now to the coastal areas in the north of England. And you can see the distribution and abundance losses are truly staggering. And this is a familiar story. This is taken from a paper by Hans van Dijk and et al. And the proposal here is that the wall brown overwinters only as a 3rd instar larva. So in the north, or when it's cooler, it can do two broods and get to 3rd instar and then go to diapause and overwinter. And in the south, where it's really warm, it can do 3 broods, have a successful 3rd brood, get to the 3rd instar and go to diapause and overwinter. But if it tries to, in the middle, where it's not quite warm enough, tries to put in a third brood, doesn't get to third instar, loses the lost generation, numbers tumble accordingly. And I know that Pete Eales has put this picture into his book as well. And Richard used it in his presentation too, I think. So yeah, there are traps for butterflies to try to respond, but don't quite make it. Now I'm going to talk about why it's not about averages. I'm going to talk about three things. I'm going to talk about microclimate, extreme weather events, and thermoregulation. And I selected this image on the right because it's a cover of a book on plants and microclimate, but it's a good thermal image of some habitat, showing the differences in temperature between some stems of grass being really cold and other areas where maybe broken ground being really warm. So I think we're familiar with this, but we don't sometimes think about it as much as we could. And this is a picture of Hutchinson's Bank, south of Croydon, which some of you may know. It's probably one of the best wildlife sites, one of the best butterfly sites in London. This area is called the Cutting. And what you'll see is, people who visit this site know it well, there are large differences in temperature as you traverse this area of the site. So if the ambient temperature was 20 degrees, the short sward would be another temperature, the grassy tussocks will be cooler, the bare ground you can see here, especially where it's south facing, will be warmer. And you might have areas here which are well above 30, and other areas which are well below 15, say. So large differences in temperature. Whoever's not on mute, if they could be on mute, that'd be helpful. Thank you. If you could go on mute, please. Thank you. So microclimate has a really big effect. And this paper, which is by Benny et al., looks at the silver-spotted skipper in Sussex. And it's a little bit complicated, although not difficult to understand. What they've been doing is modeling the thermal quality of habitat areas across in two dates, 1982 and 2000, at 5-meter resolution. So they're able to do this through imaging and computer modeling and so on. And the point about the silver-spotted skipper is that it needs the near ground temperature to exceed 25 degrees C as a threshold for activity. And the colors on these two maps, which show the same area in Sussex, quite a small area, indicate both the number of hours in the August flight period above 25 degrees C. So you can see in 1982, you're down in the blues and cooler, so it's quite a few number of hours. And there's only one site here, really, or two sites, which are occupied. The occupied means is shown by the bold outline, which are warmer. Fast forward 18 years, only 18 years, and you've got many more sites which are occupied, shown by the bold outlines, and many more sites that are warmer. So here, the local microclimate on these sites, which has been modeled, has shown to correlate with the presence or absence of the butterfly. And I believe the data for the presence or absence came from the regular study by Exeter University, who study silver-spotted skippers on a 9-year cycle throughout the southeast. But you can see how the local microclimate is affecting this butterfly. Now I'm going to talk a bit about extreme weather events and a bit about droughts. So two climatically extreme years, 1976 and 95, both had droughts. And this is the Met Office graph of rainfall in England summer. And I've just put a circle around 95 and 76. Really low levels of rainfall those years, and correlates with population crashes amongst many British moth and butterfly species. And this is just taken from the State of Butterflies report and blown up the 1975, 1976-7, showing what happened after 1976, which was a very severe drought, showing massive loss of abundance during the subsequent year and taking some time to recover. And it's farmland and widespread species, I think. And this is from a paper in Nature Climate Change a few years ago, looking at the 1995 summer drought on butterfly populations. 3 well-known butterflies, the ringlet, the green-veined white, and the large white. And you see 50, 45, 50, 60+% drops in populations as a result of in the year following that drought. So big changes. So extreme weather events are bad, and they're going to be more of them, and they're going to be more extreme. But the climate warming impacts depend on how butterflies overwinter as well. And I put this chart together for a different presentation, but for 24 species which are commonly seen in inner London, I wanted just to show to people that relatively few of them spend the winter as adults, only 5. Only 3 of these species as an egg, that's the white letter and purple hairstreak and the Essex skipper. Some of the whites spend the winter as a chrysalis, and 11, mostly the browns, spend the winter as a caterpillar. And so depending on how these respond to warmer, wetter winters will depend on how they cope with climate change. And this is a fascinating paper in the Journal of Animal Ecology from 4 years ago. And you can see how it quickly gets complex because there are charts in this paper for univoltine and for multivoltine species. But I just wanted to show this example for univoltine species with 1 brood per year, looking at extreme heat and extreme cold. So the extreme heat is in black and extreme cold in gray. And you can see extreme heat has a detrimental effect during overwintering here, negative impact on 50% of species, but a positive impact during adult periods, maybe 20 or so species being positively affected. Meanwhile, extreme cold has a negative effect during adult periods, but a positive effect during overwintering. And extreme heat or cold were defined in terms of standard deviations away from the average for that site in recent years. So you can see how extreme weather events can have quite big effects, and being warm or cold can be bad or good depending where you are. And the mantra about cold dry winters being good for butterflies is borne out. Hibernating butterflies is borne out there. But again, it gets complicated. And as Martin Moran's study showed in 2018, the global view isn't optimistic either. And this is looking at the global mean rise in temperature for species and looking at the proportion of insects, in this case, losing more than 50% of their range. And there's insects which are unable to disperse in orange and which can disperse realistically through opportunities or their own tendencies in blue. And you can see that if you get to 3.2 degrees rise, around half the species are going to suffer, losing more than half their range. So big effects on a global scale as well as in the UK. Just wanted to mention thermoregulation, because this was in Martin Moran's book and it's obviously elsewhere as well. But you'll be familiar with the butterflies which bask with their wings open, like the red admiral and the tortoiseshells and so on. These are called dorsal baskers, and then the ones which bask with their wings closed, like the small heath, and the ones which have the wings at a funny angle, which are called reflectance baskers. And I think it's no accident that the reflectance baskers have light-colored wings. They hold the wings at an angle, and this is able to bounce, if you like, the warmth, the radiation from one wing to another and onto the body to warm them up. The red admiral and so on sit with their wings wide open, and that's able to capture the heat, and the dark colors absorb more of the sun's rays. So I think you're seeing different basking. So the butterfly is able to moderate their own behavior according to microclimate and conditions as well. And of course, butterflies risk overheating. Well, these are coping with cold conditions and warming up, and seek cover if the temperature rises too high. We all know that. Just like humans seek cover. And other butterflies shiver. So the painted lady in red admiral able to shiver their wings, warm the flight muscles, and able to fly at low temperatures. So these are important for migratory species. But of course, that's why you see these butterflies feeding voraciously, because they need to replenish the fat reserves that they've used up in all this process. So the point about this is that butterflies are trying to respond to the microclimates around them as well by warming themselves up. So I want to, towards the end now, ask what we can do for insects. This guide by the Wildlife Trust is actually quite good, taking action for insects. It's promoted by the Wildlife Trust as a whole, although each Wildlife Trust has got its own promotion websites for it. But basically, the Lawton Review some years ago, which I've got a link to there in the Woodland Trust, is quite a good summary. Bigger, better, more joined up is what we need to do, so that the habitat availability for insects is there. We know that habitat loss, habitat fragmentation, habitat degradation are the problems that butterflies and moths are suffering, and why abundance is going down, even though distributions may be going up. So that's a really important point. And then increasing the diversity of habitat and microclimate. So one of the reasons that places like London are quite good for wildlife is you've got a great diversity of structure and habitat and microclimate, which different species can find a niche in. And then practically, what can people do in their gardens, in their parks and so on? Well, nectar plants for the adults, food plants for the larvae. And it's not a very long list of food plants needed for butterfly larvae that you find in places like London. Shelter for bad weather and winter, so don't strip out the ivy. And of course, don't use chemicals, and do add a pond or water feature. So all these are practical things which people can do for insects. But what about climate change? I took this data on the right from Bill Gates's book, How to Avoid a Climate Disaster. And I think he's got a good summary there of where the greenhouse gases come from. And you can see making things, steel, cement, plastic, electricity, growing things, getting around, and keeping warm or cool. Quite a good way of summarizing how greenhouse gases arise. But I think the simple truth is that addressing the climate crisis means addressing the biodiversity crisis, and vice versa. We can't solve one without solving the other. And that means we need to take action, as I described above, on the Lawton report, bigger, better, more joined up for habitats, but also for all sources of these greenhouse gases. You can't pick a mix and say we'll do one but not the other. And it needs action by everybody, individuals, governments, companies, and so on. We can't point to the government and say they're not doing anything if the companies aren't or we're not. We can't point to China and say it's China's problem when the stuff that's being made in China is being imported to the UK, and it's carbon we're then consuming, which is why I say the problem is consumption as measured by GDP. More and more stuff being consumed is the problem. I just wanted to, because we're a butterfly interested organization, talk a little bit about intensive agriculture. So the way we farm in the UK is very curious, very odd, and very damaging to the biodiversity of the country, and it's bad for the climate. So agriculture is a tiny part of UK's GDP, about 0.6%, but produces, according to Dieter Helm, 11% of UK's greenhouse gas, territorial greenhouse gas emissions. And that's because of the drive we had to intensive agriculture, so that now 2/3 of our land is farmed, 1/3 for crops and 1/3 for grazing animals, and half of the crops we grow are fed to animals for us to eat. So it's a bonkers system, a bonkers way to try and manage the biodiversity around us. So whether we get the public goods for public money, I don't know. We'll see. So in conclusion then, I think it's clear that UK butterflies and moths are good indicators of climate change and the effects of it. I think it's pretty clear that climate change impacts are here now. It's not something for the future. I think it's also clear that it's a complex picture, winners and losers. There are new arrivals, but there are extinctions. There will be local extinctions as butterflies and moths retreat, and there'll be national extinctions as some can't cope at all on our islands. So we see range expansions and contractions. We see some southern species winning, some northern species losing. We see phenology changes, positive and negative effects, and we see different effects on different life stages. And the final 2 points there are that microclimate, microhabitat are important, and extreme weather events have negative impacts. So Dan Hoare, Director of Conservation and Butterfly Conservation in the Spring magazine, said the impacts of climate change on butterflies and moths are rapid, varied and unpredictable, so we need to do everything we can to limit climate change. I think that's true, and the one-line summary probably would be that climate change is causing changes to butterfly and moth distribution and abundance. More good news than bad news in the short term, but in the long term, it's probably only bad news for most of our species. And before I close, I'm going to shameless plug for my Bike for Butterflies cycle ride. So in June, July, dates there, you can see I'm cycling from Land's End to John O'Groats, 1,200 miles in 30 days, visiting as many reserves as possible, raising publicity. And the purpose of that is to bring attention to the plight of the environment and the climate emergency. And I've summarized nature needs our help, never more than now. And it's raising money for butterfly conservation. And there's a Just Giving page there. And the Bike for Butterflies website, which you can see there, will take you to there as well. So that's me and my trusty steed. I was out cycling today and yesterday and most days since last summer when I had to cancel the ride because of the COVID. So if you feel motivated, then please do. I need to make some acknowledgements and references. And first of all, thanks to all the people, volunteers and professionals who created the data. And thanks especially to Butterfly Conservation. And I mentioned the state of moths and state of butterflies reports and the Atlas of Moths. I've referenced Richard Fox's presentation at the AGM last year. There's a YouTube link there if you want to see that. It's on the BC website. I can give you the link if you'd like it. I've also referenced a presentation by Marcus Rhodes, did for the FSC, Some Like It Hot, Butterflies and Changing Climate. Again, that's available on YouTube. Pete Eel's book, of course, I've used. Martin Warren's book, Butterflies. Trevor Beebe's book from a couple of years ago on climate change and British wildlife and so on. So thanks to all those whose work I've borrowed and reported on here. And thank you. And that's a painted lady from the migration in 2009. And there we'll stop for questions.